Now we've finished our crank, we're up to part number 28 and 29. 2 bearing crank spaces and 4 for the rear axle. They're made of 20mm wide flat bar, 5mm thick, 100mm long, 10mm holes, 80mm between the hole centres. I've cut the template off the plans. These templates are made for our bearing blocks. We purchased these bearing blocks from the internet. They're 80mm hole centres. However, you may have slightly different bearing size and also hole centres, widths, they may vary. So these are part numbers 30 through 34. I'll go and explain why we're doing this on the car. These spacer blocks are designed to get 37mm of height from the bottom of our chassis to the centre of the axle. You can also use engineering washers that are 3.5mm thick. The whole idea is so that we get clearance to the guard, and it also keeps the horizontal line of the chassis. This is a guard that we've made previously, and you can see here we've got reasonably good clearance, and it's even and consistent because these are made for our wheel diameters. This is one that we've laser cut out previously, so we'll do it by hand now. Again, this is a template that we've cut out from our drawing, or you can measure and mark 80mm to your hole centre, and we're going to make 6 of them. To save time, we've stacked 3, so that way we'll do 2 batches of 3. Our hole centre, we're doing a 5 or 6mm hole through as a pilot, and we've got timber underneath so that we can drill through into the timber. Then we'll go through with a 10mm drill. We're going to do some pre-assembly work on our rear axle and our front crank. We're going to put the following sprocket on, but not tighten anything up. It'll make it easier as a unit with the bearing blocks to put on the chassis. So these are all keywayed. If you didn't do the keyway and you've just done the grub screw method, just nip it up, but bear in mind later on we'll do some alignment work, so don't over tighten it. We've assembled and bolted our rear axle. We've done our front crank. We've also pulled the adjustment back because the next step is going to be set the chain. Notice that we've also got central alignment on the front drive sprocket and the rear drive sprocket. These, the keyways, etc., are offset in their machining as per the drawings. Same for the front crank. You need to make sure that you orientate it correctly so it all drives through the centre of the chassis. We've set up our outside hubs. Now what we need to do is centralise the rear axle to the chassis. We measure from the outside vertical face 253mm to the end of the axle, right here. Then what we can do is we lock our grub screw on the bearing, make sure they're the same both sides, 248mm. To set up our front crank, we need alignment to the chassis, but we've got 2 points of variation here where we can get free play. So what we're going to do is we're going to measure from the bearing face out 54mm so that we can get them centered on each side to the bearing block. You then make sure your crank face is nipped up nice and flush and tight on both sides. We can then at 54mm lock in our grub screws on our bearing blocks. Make sure that we keep this free movement for when we fit our chain to get correct tension. We're up to doing the chain now. We've brought a couple of lengths because the total length we'll need a few 100mm added to it. However, you could also join an old chain together to get the correct length. We're going to be opening up a pin and then we'll have to join and then close up with the pin. The total length we're going to need is 1560mm of chain length. We've got our 2 ends that we're going to join together. One end is pinned and the other end is open. So what we'll do is we'll join them together, set it up in the tool, supporting the backing piece, and then the drive pin to push the pin together. Don't overdo it, otherwise you'll drive the pin too far through. Remove our backer, lift off. We've got our bearing block pushed all the way to the back to allow ourselves forward adjustment to tighten the chain up. We've looped the complete length of chain all the way around both sprockets. So the next thing we need to do is to drive out this pin so that we can then start to overlap. You've got to make sure your internal and external chains will couple together, and then we'll be driving the pin back through to join. We slot the chain into the receiver. Make sure you adjust your backing stop so it doesn't allow any bend or movement, because once you load that up, you'll then bend this face, which is then totally useless to us. Slowly apply pressure. Make sure that drive pin is centered into the middle of the pivot pin there. Don't drive the pin all the way out. Okay, let's just check. Let's see how much more length we have to push out. Just double check. And there it is. We've got our links and pin joined together. Remember our adjustment, maximum, so we can always tension it. From this point here, we can carefully align the inner and outer, and then we drive the pin in. Remember, we need to have about 1 millimeter where the pin is sitting out, so it's a nice equal distance. Just make sure these faces are perfectly aligned. If they're not, the chain will bind and it will slip off the sprockets. So we've squeezed the pin together. We've got equal distance on sit out as far as the pin. Slight lateral movement just to free it up, because it should pivot like that if you get it right. We've done our joiner pin. Everything's correct as far as our chain now. We've also pulled our crank forward, nipped up 2 of the bolts, so we've got correct tension on our chain. Everything's functioning correctly. The final thing is we need to get correct alignment with our front and rear sprockets. We do that by measuring in from our bearing carriers, make sure everything's centralized. If it's not, the chain will slip off, it'll fall off the sprockets, so that the teeth will bite on the chain and it will flip off. Finally, we need to tighten up our remaining 2 bolts from the bearing blocks. The last step is to remove this cross member section that's no longer required. Our cross brace is here for the running boards and also the rear guards. We've done our drive system with a pedal chain mechanism, single speed chain, 1/2 inch links as per our drawings. However, you could choose a derailleur system, you could run a disc brake, you could have it electric, you could have it as a push cart, whatever you want. The drive system is actually up to you. We've finished our pedal mechanism, we're now up to the steering. The first part we're going to do for the steering is part number 37. 2 plastic conduit that we're going to be using as bushes for our steering stub axles. We've got our 16mm conduit. We're going to cut 2 50mm lengths. We're ready to fit our bushes now. So it should be an interference fit. Support the bottom and just gently tap down with a nylon hammer, if you've got one, or a block of timber. Once you've initiated it, we can then go to a G-clamp, and that will give us a little bit of extra force and stability so that it continues to go in square. Make sure that you do a lead, as in taper the hole, otherwise it can catch, grab on the steel edge and the plastic may start to collapse on you. You can see here the bottom of the G-clamp is square, sitting in the middle of the steering arm pivot, and this is also sitting directly underneath the head of the G-clamp. There's not much force required. Even a little bit of lubricant would also help if you need to. WD-40, there you go. That's done. That should be flush, top and bottom. We're up to part number 38, our front wheel axle or stub axle. We're going to make this out of 1/2 inch round bar. We'll be cutting it to a nominal length of 200mm. The first thing we'll do is we'll show you a couple of methods on how to do a 90-degree elbow with this solid round bar. Then we'll be using engineering washers as stops where we can then mount it onto the chassis. The last step is we'll be using dies and we'll cut threads so that we can then attach to the chassis and lock it with a locking nut. This is where our wheel is captured, and we also will be threading that face as well. We've got our 1/2 inch round bar. What we're going to do is we'll be using a manual bar bender. That's the most accurate method to get a tight 90-degree bend for our front steering axle. We're going to measure in 100 millimeters, and that 100 millimeter marker will then be set in the machine that we can then bend accurately to 90 degrees. We'll be leaving some overhang, so we've got a good clamping face. Then later on we'll come along, remark, cut, and it'll be set to our right length. Position, engage, clamp, and you also need to adjust your backstop. We've just bent our 1/2 inch round bar on our manual bar bender. We also need to measure and mark our 100 millimeter in length here, and on this face we have to make it 86 millimeters, but allow yourself a few millimeters more because later on we'll be tapering it and we'll do a lead in for our die nut. We've just finished doing a pair in our manual bar bender, measured, cut. We've also tapered the face, ready for the die nut. We'll show you how to do it manually now in a vise. We insert 100 mil into the face of the vise, but we're using the aluminium magnetic jaws, which are already pre-cut for round bar or tube. We then use leverage bar over the outside, and we can then start to bend incrementally until we get our 90 degrees. Small movements will keep the radius tight up against the face. Don't let it slide out, otherwise you'll create a bend out here. We want the bend point right there. We're spot on. You'll need 2 of these, so repeat the process again. We've now got our 2 stub axles. The next thing we need to do is our thread. So the short end, the 86 mil end, will have 25 mil of thread. The long end, the 100 mil, will have 20 mil of thread. It's okay to do it a little bit longer. With our die nut, we have a front and back face of the die. You can see here we have a lead in right there. So this is the face that will engage with the front. We've also got a machined recess, a female, that will line up and lock in together. Don't forget we need our thread cutting paste just to make sure the process is smooth. The most important thing in the process of cutting a thread with a die nut and a handle is you need to apply downwards pressure evenly. Make sure everything is square, the piece should be vertical, and when you apply it, don't twist or roll. You also, as you start it, go forward 1/2 a turn, come back 1/4 of a turn, continue that process until you get your correct thread depth. Even if you overdo your thread depth by a few millimeters, that's fine. Just completed the first face. Now we'll do the second face. We've finished threading our stub axle. The next thing we have to do is start making our steering arms. So let's go and have a look at the plans. We're up to part number 39. We need 2 steering arm braces. It's made of 25 mil wide, 3 mil thick flat bar. This component will be welded to our stub axle or steering arm, of which you can see in further detail on plan 2. Total length is 137 millimeters, hole centers 109.5, 13 mil hole to slide over our stub axle, and an 8 mil will connect bolt to our steering arm. This is a steering arm brace that we've previously made that was laser cut. We're going to make a set by hand. We'll use our template we've cut out, center punch the hole centers. For the second steering arm brace, we won't need to do our center punch holes, but we will mark the ends. We'll cut and make sure they're both to the same length so we can clamp them together and drill them together. To radius the ends, we can either cut it off with the power cut-off saw or the belt linisher. We can also use an engineer's file. They don't have to be perfect, they just have to be rounded off. It's more for aesthetics than anything else. We're doing a 5mm drill size as our pilot. For our stub axles, we need to set up our stop for the wheel. This is also our steering arm brace that comes out at 90 degrees, and that will also be our stop when we insert it to the chassis. Here we have our left-hand stub axle. I've set it up with an engineer's square. We measure from the vertical in 21mm. We measure then from the horizontal up 35mm. So that's our left-hand side. This is our right-hand side. Don't forget, you've got to do the opposite. We've already established that we have our heights, so the next thing for this one is we could tack it in place. We've moved over to the welding table. We've used our fixtures to help set up our steering arm and axle, where you can get it square. Repeat the opposite for the opposite side. You can also use a vise with the prism guards, orientating the left side and then opposite for the right-hand side. We finished making our steering arm and stub axle, welding it together, and that's a stop for the wheel. So we used a couple of different methods on the welding table. Now we're fitting it to the chassis. So washer and nut, and then we can try fit the wheel. Just a little tip, don't over tighten the nut. If you do, we're not going to have that freedom of movement for the steering. This washer will back up or stop right on that bearing face. And we've got clearance to the wheel as well. We're up to part number 40 and 41, our steering arm and the end mounts. The end mounts will get bolted to the steering arm plate that's welded to our stub axle. The steering arm is 1/2 inch diameter solid round bar. The ends are 20mm diameter solid round bar with 8mm hole centers. We also have a thickness of 14mm. The steering arm will be 505mm long. When we weld the ends to the steering arm, that's a total length of 525mm from center to center. This is a raw material for our steering arms and the ends. We're going to need to bandsaw 2 of these, cut this to length, and we'll finish by drilling the center out with the 8mm drill. We've cut our pieces. We're now ready to set up for welding. The 525 hole centers is really critical so that we don't get toe in on our wheels and we don't get toe out. If it's incorrect, then we'll have steering problems. Our angle line can become a drilling jig, so we drill an 8mm hole center, measure 525mm, and then drill another 8mm hole center. And you can bolt it and then we can weld it together. Make sure you get these in the center. We've made our little welding jig. Our hole centers are 525. We've also clamped our round bar directly in the middle of each of the ends. Next, we'll do 2 tacks on either side, joining the pieces together on each end. We've finished making our steering arm. We can now move on to the steering arm mount or lock. Part number 45. It's 40mm wide flat bar, 125mm long, 3mm thick. We need to cut this template out so that we can draw all these lines, and we also have some drilling and some elongation of holes as well. This is for the steering column, and later on we'll be welding this part to the steering arm. This is part number 45 that we've previously laser cut. That's ready to fold. This one we've cut the template out of the plans. It's 1:1 scale. We can then center punch our holes to be elongated. You mark the outside, cut with a cut-off disc on a grinder, then we fold. The drilling will go 4mm, then 11mm. We've cut out our bracket. We now need to mark our fold points. We've got 2. We're going to see the angle here off the plan, which is 34 degrees off the vertical. Set your angle gauge or sliding bevel. You then mount your piece in the vise and bend it until you get your 34 degrees. The second way is using a flat bar bender. You can do both bends in the flat bar bender, or you can do it in the vise. We've finished bending up our steering lock bracket. We've also finished our steering arm. These two will be welded together at a later stage when we are on to drawing 5 and we're making the steering column. We're up to drawing 5, the steering wheel and the steering column. We'll start by making the steering column, then we'll be doing the bushes. We'll also be making the steering rod, the hub to mount the steering wheel. You'll be doing the base out of steel and also the support ring. Then we'll be passing you over to Ezio to do the timber. Finally, it's the steering column mounting bracket that will be welded to the chassis. We're up to part number 46. It's 38mm tube, 1.6 wall, ERW, electric resistance welded tube, 605mm long. We'll be drilling 2 holes for nutserts at a later stage. Our steering column will cut at 605mm, then we'll measure 200 and we'll do the hole for our nutsert. The other nutsert will be done when we're actually mounting the steering column to the chassis. We're going to mark our first nutsert. We measure up 200mm and we mark it. Then we'll center punch. We're up to doing our nutsert. We're going to use a steel nutsert because when you squash it in a round tube, your purchase area is not quite as good as if it's a flat piece. Aluminium does tend to slip a little bit as a nutsert. We're going to need a 9mm drill to drill out our nutsert, so we'll do a 4mm pilot hole and then a 9mm drill. Now we've finished our first nutsert, we can then turn it 180 degrees, find the flat spot. We then measure in 35mm, mark it. So at the very top of the tube, we center punch, drill, and repeat for our nut insert. We're up to part number 47, the nylon bushes for our steering rod. We need 2 of 35.6 OD. It's solid round nylon. 10mm hole center, 25mm wide. First thing we're going to do is measure and mark our 25mm. You can cut it in the bandsaw or a hand hacksaw. Don't use a power tool to do this. So we're going to need 2 of them. Then we'll be marking our hole center, drilling the 10mm hole. You don't need to step in increments because it's very soft material. This is an interference press fit into the steering column. We don't want it loose. We've tapered the edge here with a bastard file or very coarse sandpaper like 36, 40 grit, etc. That way we've got a slight lead in to help us, and we've also tapered the holes as well. We're up to pressing our bushes at each end. There's multiple ways you could do this. A sash clamp, a carpenter's sash clamp to draw it in. Just make sure everything's square. You could use threaded rod or Brooker rod with flat washers and nuts, and that will draw both in. We're going to press it in by hand, just a simple block of timber and a hammer. The other way you could do it is also a hydraulic press. We've fitted both bushes. During the process of fitting it, the hole's closed up a little bit, so we're just going to re-drill it with a 10mm drill bit, just to give us a little bit more clearance to our steering rod. We're up to part number 48, our steering column shaft. We need to cut it to a length of 850mm long. It's 10mm diameter, bright mild steel bar, grade 1020. One end is going to be threaded, the other end will be bent, and then we weld washer so that we have a stop on the back of it. We'll also be trimming each end a little bit later on. We'll just measure our steering shaft, 850mm long, and then cut it in the bandsaw or power saw, however you want to cut it. We're up to bending our steering shaft now. We're going to use our flat bar bender, which is also recessed for a round bar rod, and we'll be doing it incrementally and sliding it through the die. Follow the plans as far as the radius and the measurements. And the other way we're going to do it is just some simple tooling here on the vise and then using leverage. This steering shaft can be done a number of ways. You can also make up a jig to bend our radius for our steering arm. We've measured in 35mm and then 10mm, so in total we have 6 bend points. Each bend from the first mark will be 40 degrees. We've gone as far as we can in the bar bender. The last piece we're going to have to do in the vise, and if we can, around a solid round bar. Okay, a little bit more. There you go. We've just finished doing this in our flat bar bender. Now we're going to show you how to do it manually using a 30mm solid round bar. With our 30mm solid round bar, we're going to use this as our internal radius. We've got our 10mm bar at 90 degrees to the 30mm bar, pinching it in the vise. Then what we do is we use pipe for leverage and work our way around. We've got a twist in this because it's had to wrap itself around the vise. So what we're going to do is clamp it in the vise jaws and then correct that twist. We'll just close this up in the vise with a little bit of pressure. We just simply bring that point back down. This is one we've just finished making in the vise using our 30mm round bar. You could even use slightly smaller, say 27mm round bar. The last few pieces of radius we've had to manipulate a couple of times, pinch point, etc., leverage, using our pipe. So you're going to find it's a little more problematic. We've got a few marks from the vise that we're going to have to clean up. However, this came out of the flat bar bender, good to go. Now we've got our steering column bent. We overlay it on our 1:1 scale plans. We could then mark. If you don't have 1:1 scale, we can then measure from the end of the radius, 55mm, mark, we'll weld the washer, measure 605mm where the thread stops for our steering wheel. We've measured 605mm from our steering stop washer. This section will be entirely threaded, then later on we'll trim it off because we've got washers, jam nuts, steering bosses to fit, including the steering wheel and a dome nut. We've cut this to length. We're now going to do our M10 by 1.5 thread using Trefilex and our die. Don't forget to do a lead in. We've marked where the thread stops from the drawing. We've allowed an extra 10 to 15mm, so you'll be threading a little bit more, but later on when we use a dome nut to lock the steering wheel on, we can then start to trim down to the exact length. The same on the bottom as well, allow a little bit of extra. I've done 2 tacks on our steering stop, so only one face gets welded. Remember, the steering column butts up on the inside here. Well done on making the drivetrain and the majority of the steering components. In the next episode, we'll be making a steering wheel. If you've already acquired a steering wheel, you can move forward to episode 9. Where we'll continue the assembly of the steering components.